let us get started. So yes, the main idea of this project is really to explore the use of large language models for natural language processing for the construction of a knowledge graph. I did this with students from the International Semantic Web Summer School last summer. It was basically a project we did in roughly 4 days. So they were incredibly productive under a lot of pressure, and I'm pleased to be able to present their work here. Yeah, so one of the issues, the reason that we are looking into this, why do we want drug indications? Well, they are the approved uses of drugs, typically from a regulatory agency. But why do we want the medical context? The medical context is all the contextual information about the approved use. Okay, and it can be involved the target population. It could be the line of medications that have to precede it before you get to that. There could be other information relating to just the prescription of this for a particular subgroup. And the reason we want to do this is because we do a lot of work in drug repositioning. We want to predict new uses for existing drugs, but you don't want to predict a use that is incorrect. There are many examples, such as IBM Watson, that have invented, I mean, this is one of the challenges of AI, they will invent potential applications of a medication. But common sense might exclude some of these potential applications. So we want to be able to make sure we capture this important approved medical context when we are trying to make decisions with AI agents. This is the motivation. And currently, there are no such databases that capture it in a structured format. And if we had it, maybe AI devices like IBM Watson would not provide incorrect or unsafe recommendations. Yeah? So here's an example, right? The drug indications are captured in the drug product label. So every time you get a medication, a prescription, you open the box, you get a piece of paper, and it will state in there what is the approved use of that medication. Okay, so it looks like this. So Emgality is indicated for the treatment of episodic cluster headache in adults, right? So we can see the product is Emgality. This is the product name. It's indicated for, and the action is a treatment action. There are other kinds of actions, right? So it could be done in a preemptive manner, or it could be in symptomatic relief, or all kinds of things like that. And the condition is episodic cluster headache in the target group of adults, right? So this is what we want to do. The general idea is, can we take this sentence and create a structured representation of that? Yes, so in our work, we identify a number of these so-called medical contexts, the target group, whether it is an adjunct therapy or used in co-therapy, the duration of the treatment, whether there's a genetic component to it, whether it's for symptomatic relief, for an underlying condition. So we're trying to stratify or extract out these information along these categories, okay? So again, most of the databases that contain drug information, they don't capture this medical context. They just give you drug treats disease. And even then, it is not always correct. Even then, you will see drug treats an underlying condition, but actually what it treats is the symptoms of the condition. It never treats the disease. It just gives you some kind of relief from the condition. Okay, so we really need to extract this in a machine-readable manner. And but this hasn't really been done for these this kind of text, with the exception of some of our prior work, where we manually curated a database of neurological medications and their medical context. So we did that by hand. We had a set of categories. We used a tool. We did some extraction. We created this NeuroDKG. With a number of statements, including the medical context statements, and publish them as nano publications. Okay, so this is kind of our first work, but it was done in a manual way. It took a long time. It was very difficult to do. So our idea in this project was, given the astounding, exciting aspect of large language models, could we use language models to extract, to identify these components and extract them into a structured form? And then from this, we make a knowledge graph, a semantic knowledge graph. So this was the main idea. So we take text, which comes from the drug product labels. We use a language model here, namely GPT-4. We used an entity identifier recognizer, which is the NCATS translator SRI name resolution API. And then we write a script to convert the extracted JSON into an RDF graph. Okay, and we call that DiamondKG. So here's what we wanted to answer. How prevalent are medical contexts? Right? So I gave you this one MGLT for cluster headaches in adults. This adult part is the context. How many indications of all the indications we explore have contextual information? What is that? We don't know, right? That is what we want to answer first. We would like to know then, what is the impact of changing the prompt on the quality of the output? Okay, because of course, large language models do in-context learning. So you provide some input and it provides some output. So the quality of the output depends on the quality of the input. We want to explore that part. And finally, we want to look at what is the quality of this generated graph to compare it to NeuroDKG. Do we extract what people extracted? And then going beyond that, when we find new categories, what do those look like? Okay, so I include here example of a prompt or the prompts that we use. We had 3 prompts. One was, can you extract some triples from a sentence? The standard subject, predicate, object extraction from a sentence. The second one is identify a context for these sentences. So can you extract automatically context without me telling you the context to look for? And the third one is, I have all these categories of context. Can you identify and populate these contexts from the text, from the sentences? Yeah. Okay, so when we do that, we have, you can see here the comparison against NeuroDKG. NeuroDKG was a much larger knowledge graph, but we focused on the ones for which we could do an extraction for. And that ends up with 510 triples. We get a number of different triples for each of the prompts, 442 for prompt 1, 911 for prompt 2, and 620 for prompt 3. And from this, we can estimate also the context frequency. So we have, even in NeuroDKG, what of the sentences that were manually curated, 64% of those sentences had context information. In our automated extraction, we found 71% of the sentences. So the answer is somewhere probably between the two, okay? So this gives us our answer to the first research question, right? Somewhere between 64% and 71% of the sentences that are related to neurological disorders have a medical context. The second then is the population of these medical contexts. So here you see the comparison between NeuroDKG and our DiamondKG. And there are some differences, right? So for instance, the target is the intended indication. That is, what is the actual condition that is intended to be treated is the target one. Okay? You can see in NeuroDKG, there are far many more of these and less here. Okay. The other is in the symptom. So this is where there is a symptom mentioned in the drug indication. But there is some problem here in the semantics, because in some cases, the symptom is also the one that is being treated. And then other times, they're simply mentioned as a comorbidity, something else that also occurs for the indication. But otherwise, for age group, it's somewhat similar, and we get some others here. And then we also identified a few other categories that weren't being curated there. Here's an example of text where actually both have some problems. All right, Xyrem is indicated for the treatment of cataplexy or excessive daytime sleepiness in patients 7 years of age and older with narcolepsy. Right, so again, the indication is cataplexy or excessive daytime sleepiness. So these are things that we're trying to treat. But the underlying condition, the reason that people experience this is for people who have narcolepsy. So this is when they're diagnosed with that, they sometimes have these as symptoms, right? So the medication is intended not to treat narcolepsy, it's intended to treat cataplexy or excessive daytime sleepiness, right? So NeuroDKG identifies, so the people correctly identify cataplexy as a symptom for the underlying condition, but incorrectly identifies narcolepsy as the therapeutic target, right? And there's this semantic difference that we really wanted to establish, right? Where you have symptomatic relief versus treating the underlying condition. In DiamondKG, we classify cataplexy as a symptom of the underlying condition, But narcolepsy is incorrectly characterized as a comorbidity rather than, again, the underlying condition. So we have more work to be done, even though we have done some extraction. Now, that's a comparison to NeuroDKG. We also annotated all the sentences ourselves again. For the types that were the expanded set of types that we were including. And then we did a comparison of the automated extraction versus the manual one. And so what we find is we get an F1 score across all context types of about 64% and a weighted average of 74%. And this is what we see for each of the individual contexts. So we have an 81% precision for the target, 67% for symptom, and 91% for the target group. So we seem to be pretty good at extracting the target group, which is great. But maybe a bit more work has to be done for these categories. But you can also see that the frequency, the number of such instances for all the categories can be quite low. And therefore, these are not very reliable metrics of performance when you start looking at things that have 3 or 8 or 6. So we need to curate a bigger collection of these. Just suffice to say they occur infrequently as a context in the corpus we examined. Okay, so when we look also at the kinds of errors that we have, we see that for the pairs between the annotated ones and the predicted ones, we have 18% that are wrong pairs, so pairs that are not present in the ground truth. They're misclassified pairs, about 10%. So we identify something, but it's in the wrong context type. And then we identify 8% where they are in the ground truth, but not present in the output. Okay, so what we have done in this relatively straightforward experiment is see, can we use GPT-4 to do natural language processing, to do some recognition of these contextual medical indications, which hasn't been done before, and to compare that to NeuroDKG, a manually curated database. So we seem to be doing pretty well, but we have some misclassification errors, right, on both sides. But at least we answered the first question, which is it looks like we have somewhere between 62 and 70-something% of the sentences have context information, which is higher than we maybe expected, which is very important. Obviously, if it was only 5% of all sentences, this wouldn't be an important problem. But because it happens in about 70% of all sentences, we should pay attention to this kind of information. It's important. And it's specifically there for prescribing, but arguably it's also going to be very important for drug repositioning. In the second question, we look at, so what is the impact of changing the number of contexts, or changing the quality of the context? And we do improve the extraction of the context as we go through. But interesting, when we use the context, or the context number 2, we get many automatically extracted medical contexts. Actually, we get about 150 or something, which is more than about the 14 that we were looking for in prompt number 3. Yeah, so we have to examine that. What did ChatGPT or what did GPT find as a context? And then can we refine and augment the categories of context? Because we also just started with a few and said, here are what we think are the classical medical contexts, but they're actually more being extracted. So what are they? So we need to re-examine that and perhaps reclassify or create, refine our classification. And then finally, we have this RDF graph. I had an updated presentation. It is not here. So it's an RDF graph. You can, I think it is here. It is available at this address, so you can download the graph and you can examine its contents. But the idea of that graph is it just simply captures the sentence and then the contexts that are there, or the various parts of the extracted part. So it doesn't make an RDF graph in the sense of drug treats disease, or that this sentence has a particular, this triple has a context, but it is much simpler database of capturing extracted contexts. Yeah. Okay, so with that, I think I will simply acknowledge that the funding that we have received from the International Semantic Web Summer School, if you are a PhD student and you're looking to improve your skills in semantic web technologies and other related technologies, including machine learning, this is the summer school for you. and also thanks to some of our funding from the European Union. Okay, with that, thank you for your attention.
Thanks a lot, Michel. Great talk, very interesting. I was wondering how much normalization effort you had to put to compare the response from the LLM to your annotations.
Yeah, so the NeuroDKG had done some curation of the concepts that they were using for, I think, both the conditions and things like that. In the SRI name normalization system, we can also resolve for the same identifier, target identifier space. So we didn't do anything more than use the service to do the identifiers. Yeah, so that's name normalization service comes from our project that we've been running called the NIH Biomedical Data Translator Project. And this is one of the things that you are interested in doing is doing entity concept recognition or entity labeling or mapping. And this is a nice API service to use across many different biomedical data types, diseases, drugs, phenotypes, things like that.
Hello, Yanis Mimouni from Inserm. I have a question regarding the source of your project. Here you mentioned that you have used the drug label, but have you considered using the summary of product characteristics where you have much more context regarding the pharmacokinetic, pharmacodynamics, and the other genetic information? And also, relating to that, have you looked at the bias of using GPT-4, your LLM model, if it was trained on this summary of product characteristics and thus infers the context from the label that your not the diamond, the other model is not capable of doing because you have annotated manually?
Yeah. Okay. Thanks for your question. So no. So we use just the drug indication section of the FDA's Daily Med database. So that comes as XML data files or with the API, and you just extract literally that section. So that's the only thing we looked at, which is a pretty succinct, usually includes a succinct statement of that indication. For what, sorry, for the second one was? Okay. Yeah, well, we don't know, right? And in fact, that is a criticism, is using a commercial model, is we also don't know the data sources. And that is why in our group, we have started looking at some of the other models like Mistral and other instruction-tuned models, and to see what their performance is to compare to this one. But I mean, I think this is something they tried to do in 3 days, and they didn't want to mess around too quickly, and it's quite responsive. So it's a good point. But I arguably, it did not hallucinate. Let's say it didn't create, because the idea is you give it the text and then you ask it to do from this text. And with the instructions we provided, we didn't see it generate an output that was not from the text. Or if this happened, it was extremely infrequent. So it would be less than 2%, I would argue.
Hi, thank you for your talk. It was really interesting. I was wondering when you're, deploying the LLM approach to this kind of thing. I think you do have percentages, and some of them impressive, but in the context of what you're looking at is treating humans with with problems and things, that it's important, I think, to think about what are the impacts of a wrong decision. So in one context, 70% is really great and fine. In another one, it could be, bad for 30% of the folks that maybe there's some kind of poor outcome. And then the idea that you have sort of these standardized, more or less, labeling that you're deriving from. And so it's been proposed that using the knowledge graph in combination with something like a large language model would increase your accuracy for these kinds of things, and especially in this kind of context. So what are your thoughts on combining those two?
Sure, yeah, good question. Yeah, so again, I'll just reiterate, this is a very early idea just to explore the language model more or less on its own. So these are the results of that experiment. But arguably, you can do a lot better. And I think both in terms of, again, you have the in-context learning, which is what can you provide in the prompt? And there have been many advancements in prompt, for instance, few-shot learning, analogical reasoning, all kinds of different strategies to improve the outcome or the analysis output. That is at least a first part. The other is retrieval augmented generation, where indeed you could refer to an external data source, a structured data source like another knowledge graph or database, and use that to influence then the recognition and generation task. So absolutely, our view is that current ongoing work explores the use of external data sources to improve the extraction part. I would argue also, I mean, a bit of your comment is that this is for research purposes. In no way am I ever claiming that graph is going to be used for clinical care. That is not the case, but it is really a question about how effective are the language models for this natural language processing task that in our arguably zero shot, although we don't know that it has not seen such text, it probably has, but it's a more general model than one specifically tailored for drug indications, let's say. I hope that answers your question.
Thank you. We have a question here.
Hello, Joe from SciBite. Thank you for a fantastic talk. I think it was a really cool overview of the kind of things that you can do with LLMs. I understand that it's more of an R&D project, but I'd be interested to know thoughts on operationalization of approaches using LLMs and particularly commercial LLMs. If you were to ask and provide a sentence and ask for it to identify the context of the entities, obviously there's one prompt and get what you kind of ask for, but there's obviously an iteration there potentially where you can dive into more details. So I was just wondering if you guys considered some of the operationalization pieces when looking at that research, cost, time, blah blah blah, some of the boring stuff.
No, it's not boring. Actually, it's arguably essential. So, I mean, for those of you that have had the pleasure to work with large language models for tasks that you have daily tasks for, you realize that it can help you save time, but in no way would you ever automate or delegate the task without review. So it's very useful as a first pass in some sense, as a constructive co-creator of trying to accomplish something. But what I think all of us acknowledge is that there needs to be a workflow to ensure the quality of the output if you're trying to do an automation task. There we see a lot of really nice, good LLM orchestration frameworks like LangChain and other things like that, where you can introduce then computational components to process, vet, iterate, and eventually get to the outcome, the performance levels that you think are acceptable for an automation of a task. So I would say just doing in-context learning probably won't get you the level of performance that you can use for automation. I would not do that.
Absolutely agree. Thank you.
Thank you, Michel, for your presentation. I was wondering if you have thoughts about using the same technology for the creation of, for example, Sparkle queries that can trigger several knowledge graph, or also the use of the same technology to move from one knowledge graph representation to the other, probably with the Sparkle construct that is capable to recognize it by using this kind of technologies.
Yeah, good question. Actually, I think one of the very first queries I ever did to ChatGPT was write a Sparkle query against FAIR RDF for drug indications. And it kind of did it, which was super impressive. And then we started a project then to use retrieval augmented generation to support the construction of Sparkle queries from our schema. That vastly improves its generation capability. So I think that this is the general idea, is to augment these methods.
Thank you.
Okay, thank you, Michel.
Thank you.